That's good, go.
When checking the engine oil, it's critical that the level is right after the engine's been shut off after running for a short period of time. You want to check the oil. When you pull the dipstick out, there are two factory marks. You want to be between 1/8 and 3/16 of an inch above the top factory mark. This is the best place to keep the oil for your Formula V engine. To check the oil on your V engine, the dipstick is right below the fill area. So as long as you can pull that out and have a look, you see that the oil is on the dipstick. Check the level, clean it off. You'll see where the marks are. Make sure the oil's in the right spot when you check it again.
All right.
Okay. So to check our transmission fluid level, there's a 17mm internal hex plug on the side. You can either use an Allen key if you can get to it, or there are tools available. You have to undo the plug, remove it, and the level should be about 3/8 to half an inch below the opening of the hole. So the easiest way to check this, if you have access, you can do it visually. If you can't, very carefully without rolling the car or anything, stick either your finger or a tie wrap down in there, and you should be able to come up with the end of your finger being wet with transmission oil. The level is not extremely critical, but as long as you're somewhere between the 3/8 to half an inch below the top, your transmission's fine.
We're recording.
When it's time to do the alignment, first thing you want to do is make sure your steering wheel is in the straight ahead horizontal position. When that's in place, you can put the trammel bar to the front of the car. Normally in this situation you would have either the driver or the equivalent weight of the driver in the car to make sure all your measurements are accurate. Place the trammel bar in front of the car, and what you want to do is reference to two grooves. Tire on the right hand side, tire on the left hand side. Once you have the bar with your partner positioned on the one side, you can adjust the trammel bar to be centered in one of the grooves, whichever groove you reference to. Make sure you do the same thing on the rear. When you've done this, you now have a measurement from the front. Now you go to the back side of the tires. Once you come around to the back side of the tires, if you put the right side in the groove and you come up to the left side, you can reference where you're at. In this particular case, we have zero toe in or out because we have the trammel bar back in the exact same groove we had on the front. Driver preference, different tracks might change slightly, but basically this is where you want to be doing your toe setup. If you've determined that there needs to be a change in the toe, you can check from the inside of the wheel to the center of the upright to find out if the measurement is equal. As long as both wheels have the same offset, this will work. Then you can determine whether the one tire either side needs to be towed in or towed out. If you need to make a toe adjustment, you have to undo the jam nuts on both ends of the tie rod. One is going to be left-hand thread, one is going to be right-hand thread. You will turn the tie rod to either lengthen or shorten the position of it, which will change the toe in or toe out of that wheel. It takes very little movement. Lock them back down, go through the process of checking your toe again.
There you go.
On the rear suspension, we need to check the camber of the rear wheels. The camber is going to be the inward or top of the wheel tilting in towards the car. Most cars, it'll be a driver preference, this will be a tuning item, but on most cars you will want somewhere between a total of 4 and 6 degrees of the wheels tipped in. This will depend on the driver. This has to be done with the driver weight in the car. Since we have a zero roll system, you do not have to be on a perfectly level floor. It will be a combination of measuring your camber angle on each side of the car, totaling it up, and that will give you the amount of camber you have at the moment. And it can be adjusted either by lengthening or shortening the push rods or by winding up your spring or unwinding your spring on your shock. One of the most important things on the rear suspension of your Formula 1200 is making sure that the droop limiting of the rear wheels is within range. The droop limiting is the angle of the rear wheels not going into a positive position, which will make the car evil, very hard to handle. So what we do is we take one wheel, and with our camber gauge, we set the one wheel to 0, and then we will go around to the other side and measure what camber we have on that tire.
Go.
With your other side set at 0, we now come over and measure this wheel. This wheel will show somewhere in the range of half of what you have in total camber. If you're running 6 degrees on the back of your car, your droop limiting will want to be about 3, which will mean you will want 3 degrees negative on this wheel when that wheel is in the 0 position. Whatever you end up running, if you go down to 4 degrees of total camber with your driver in the car, then you would drop this wheel to 2 degrees. You want to have about half of your total number of camber degrees in your droop limiting.
Go.
Most zero roll systems will have what they call a droop limiting rod or droop limiting bar. It will be adjusted, it's threaded. If you shorten the bar, you will have less camber droop. If you lengthen the bar, you will have more camber droop. Make sure you use this to adjust your camber to keep the droop limiting in the correct sequence. Most zero roll systems will have externally adjustable shocks. The canister will adjust your compression, which is a knob on the bottom, usually has somewhere between 6 and 12 adjustments, and your rebound is adjusted by an eyelet inside the end of the shock, removing a needle and seat valve inside. If you need to make a change to promote or correct oversteer or understeer, the rebound adjustment is the more likely place that you'll want to start. The compression will change spring rate slightly, but has less effect on our zero roll cars than what the rebound adjustment has.
Let it go.
Rear toe in is set the same way as the front toe in is. Once you have your determination of how much toe change you need on a forward facing trailing arm car, it will likely be adjusted in something like this. On a rearward facing trailing arm, it will be adjusted at the rear of the car, the other side of the axle.
Go.
This is an example of a rearward facing trailing arm car. The adjustment is made the same. All you're doing is lengthening and shortening the rod to move the wheel forward or backwards. The adjustment's exactly the same.
Go.
Due to the location of batteries in most cars, it's difficult to get onto the battery to get the charger in place. One of the easiest ways to do this is put your positive cable on the main heavy wire connection on the starter, put your ground cable somewhere to ground on the chassis. If you turn the master kill switch on, being sure that all your other switches are off, you will now charge the battery in this position. When everything is done, shut the master kill switch off and remove the cables.
Go.
When it's time to adjust the valves, we need to find number 1, top dead center. Cylinder numbers are number 1, number 2, number 3, number 4. Rotate the engine, bring up the top dead center mark. Be sure not to use your full advance mark, but bring it up to the top dead center mark. Take the distributor cap off and make sure that the ignition rotor is pointing to the number 1 spark plug wire. When you have that situation, you now know that you're on top dead center number 1. If you remove the valve cover, pop it off carefully, you'll be able to check the exhaust and intake valves on number 1 cylinder. What we're looking for here is about 6 thousandths of an inch of clearance. If they're too tight, as these ones are, or too loose, the process is cracking the jam nut loose, and you turn the adjusting screw either in or out to make your adjustment slightly. Lock it back down again. Check it again with the feeler gauge, being sure to keep everything clean all the time. Once we have it so that there's no free play, but the feeler gauge slides in and out, you're done on that particular valve. You go to the next valve, adjust it the same way. When it comes time to go to the second cylinder, Volkswagen firing order makes it quite simple. If you turn the engine counterclockwise 180 degrees, you will come to the next cylinder, number 2. If you go another 180 degrees, you'll come to number 3. Another 180 degrees, you come to number 4. So if we take an 1.25 wrench, and we turn our pulley backwards until we come up to our bottom dead center mark, lined up with the split in the case. All your timing is done with the split in the case. We have our bottom dead center mark lined up. We're now on cylinder number 2. We can adjust the valves on cylinder number 2 the same way as we did on cylinder number 1. When we're happy with the situation there, again we go back to the pulley, turn it counterclockwise 180 degrees again, which will bring us up onto cylinder number 3 to adjust. So you can adjust one side of the engine at a time. Your valve cover can go back on this side. You can go over to the other side, do 3 and 4. Remember, you go 180 degrees backwards to your timing mark, and the job is done. It's that simple.
Why did we have it?
Sorry.
Why did we have the engine? Do we have to take the engine out to do it?
Oh, okay. For simplicity, we removed the engine from the car. It will vary on every person's car as to how you get to the valves and everything, but the bottom line is this is what you have to do.
Great. Go.
Both valve adjustment and spark plug removal have to be done when the engine is stone cold. Remember, when you're putting the spark plug back in, start it by hand. Make sure it's not cross-threaded. You're going into an aluminum head. Be very cautious with the torque that you use on it. Engine removal from any of the cars will be similar, but obviously slightly different depending on the car. Throttle linkage, electrical connections to distributor, sending units, everything like that will have to be removed. Fuel lines and everything have to be removed. The exhaust system will have to come off normally. Most cars, the intake manifold has to come off. The manifold is a very fragile piece. When we're removing and replacing the intake manifold, great care in handling it. It will dimple and crack quite easily. Be very careful with it. When you lift it off, be sure to plug the intake holes in the head so that nothing gets in there. Some engines will have a front mount. Some cars will require that the fuel tank or other pieces need to be removed, but the main thing holding your engine in is there are 2 bolts going through the top. There are 2 studs on the bottom that mount the engine to the transmission. Any of the other extra pieces attached will be specific to your car, but basically the 4 bolts and nuts are the only thing holding your engine into the transmission, holding it to the car. Okay.
I'm just about out of battery fluid here. Go ahead.
When removing the engine, you have to be very careful not to damage the pushrod tubes underneath. It's very thin material, it'll dent quite easily. And as you lift the engine out, don't put your hands past the solid edge of the head, grasping it like this. One person on each side, you'll easily be able to lift it out of the frame of your car.